we're going to talk about an ellipse. Now, you've seen ellipses in the planets, the orbits of the planets, they're elliptical. The one thing about the elliptical planets, their center is not exactly in the middle of their ellipse sometimes. Sometimes they rotate a little bit differently around an ellipse. We're only going to do ellipses where the center is exactly in the middle.
There's two focuses, right, in the ellipse?
There's two focuses, and we call them foci. Good. And they're equal distance from the center. It's kind of like a circle. It has the same concept of a circle with a center. And in fact, an ellipse is a circle is a special kind of ellipse that we'll see in a little while. And if you kind of look at just the numerator, with the x minus h squared plus y minus k squared, that's part of your circle formula. The denominators will be different if it's an ellipse, because that's what sets it off lopsided, kind if you will. But I just need you to add these two pieces of information. We're going to be finding A, B's, and C's in here. And A is the distance from your center of your ellipse to your vertex. You know, it doesn't mean that much right now. B is the distance from your center to your covertex. And C is the distance from your center to your focus point. Now we have two focus points that are equal distance from the center. We call them foci. Like radius and radii. They're foci points. We have standard equations for these guys. Now how to tell the difference is, notice they're both square. The parabola only has one variable, that's square. And we have a plus sign. That could make it a little bit like a circle. But what makes it different from the circle is the fact that A and B are going to be different values. If they were the same, we could multiply out by that and we would have a circle. Like if I did this, x minus 1 squared plus y plus 1 squared equals 1. And I had a 9 under both of these. If I multiplied every term by 9, you get your formula for a circle. Equals 9, which is your r squared. So a circle is a special kind of ellipse. Normally, these two denominators are not the same. They're going to go oblong. One's going to be longer, like stretched out more than the other one's going to be. So it gives it that oblong effect. Right? And again, we have some nifty little formulas that are not as important to memorize again, because we're going to place these on your graph. And believe it or not, these words are going to make more sense than memorizing your formulas. What you do have here is a major axis versus a minor axis. If your ellipse is this way, long, the major axis is the y-axis, whichever way it's longer. If your ellipse goes this way, then your major axis is your x-axis, your horizontal axis. If we move it off the center, then it's just the horizontal translation. So we're going to see that in a minute. And we're going to see what's important here is if you circle your a squared. Where a squared is going to be whatever number is larger in your denominator. That's going to be, if you look above it, the letter of that one is your major axis. So we're going to see that in a minute. Okay? Now, I changed your note page just slightly. Oops. Where was that? I changed it slightly. Cross out the one that it says there on the left. Now that's a homework page. Oh. Your note page is this, where we're going to work the problems out. Cross out the first problem. And if you'll write this problem, God bless you. I started out way too difficult, and I want to make it easy. Now, which number is larger, 16 or 25?
25.
25. So, this is your a squared. This is your b squared. You're going to set up an a, a b, and a c. Now the one that's larger is the major axis. So we look above it and we say, the y. That means my ellipse is going to be oblong going vertically. That's going to be the major axis. Normally, we have this, x minus h squared, y minus k squared. If there's no value of h and k, then what would the center of my ellipse be?
0.
0, 0. Okay, so we're going to start real easy. Because the larger number is the a. God bless you. The larger number is going to be our major axis. So we start like this. We start at the 0, 0. There's the center of your ellipse. Now, notice, and this is an easy way to remember it. This is squared in the numerator. This guy is also squared in the denominator, right? Y squared and a squared, x squared and b squared. See it? To find a, we have to take the square root of 25. 5. To find b, square root of 16. 4. Now, we had a neat little formula there on your note page that said this. C squared is equal to a squared minus b squared. You kind of have two ways to do this. You can substitute back in your a and square it, or you can go to where a square is and pull out the 25. Either way, it works out the same way. Yep, you can either use the 5 or the 4, or you can come where a square is and use the 25 and the 16. That's whatever you decide. So c is equal to 3. Now, even though we took the square root, we always take the positive, because we're measuring a distance. A distance from the center to a vertex, from the center to a foci. Distance is always positive. So here's all we have to do. To say, our center is here, at the 0, 0. Our major axis is the y. So therefore, we're going to go up 5 units from the center to the vertex.
Okay, so
the major axis is the y, because that's the larger number. So along the y axis, we're going to go up and down 5 units. A is the distance from the center to a vertex. So if my center here is at 0, 0, what's one of my vertex points? 0, 5. If I go down 5, 0, negative 5. Now, my minor axis is now this guy, the x-axis, where the 4 is. We go over 4. This is called a covertice. It's kind of like a pilot and a co-pilot. The pilot is the major guy. The co-pilot is the minor guy. So this would be 4, 0. We go, whoops.
a squared will always be the major.
A squared will always be bigger, and it could be either on the right-hand side or the left-hand side.
Okay.
If you kind of realize that a squared is going to be the larger, because we do a squared minus b squared. We never do b squared minus a squared.
But the y squared and the x y would change.
They also could change positions.
Okay.
It could also put the y squared first, like this, because this is just saying commutative property. X does not have to come first, because we're only adding. Can't we swap the, like 3 plus 4 versus 4 plus 3?
Will y squared always be equal up with a squared?
Nope. Whoever's the larger number is the a squared.
Okay.
In the next problem, we're going to switch it up.
You said that you can do 5 and 4. I did it, and I got 1.
You got 3.
I got 1 when I did 5 and 4. 5 minus.
No, 5 squared.
Oh,
5
5
squared.
squared. Okay.
Squared. That's why you could either do the 5 squared or come up here where it's squared already.
I thought the 0, 5, and the 0, negative 5 was the focus.
Nope, those are the vertex. A is the distance from the center to the vertex. So now this guy's going to come out here, another co-vertex, negative 4, 0. Now, here's my ellipse. A little longer than it is wider. I apologize off the bat for my elliptical drawings here. They're horrible. It usually looks like eggs. So, if you remember, we're looking for the larger one. That's the major axis. That's where your vertices are. Your co-vertices are on your minor axis. That's what helps us draw your ellipse. The distance from the center to the vertex versus the center to the co-vertex. Now the focus is what we found for C. The C distance is from the center to the foci. So we go from here up 3. So this would be 0, 3. And from here down 3. This would be 0, negative 3. Okay?
So we need to label all those out.
Yeah. It's not that bad though.
That's actually really easy.
Wait, before the focus one, y3.
The focus is the distance between the center and what we call the focus point. Now your focus is used, if I don't want to move this, but if you refer to your note page, see how your foci are used on the note page? The distance like this, and I didn't want to really draw here, but if you go like this, or you go like this, and like that, or from here, all the way here to here, all those sums would be the exact same. That's a normal ellipse, where your center is smack in the middle of your ellipse.
Oh, so to find that point, I'll use that formula that's on here?
That's all we're going to use is your formula. We're going to find the A and the B from your equation. We're going to find the C from this formula. And we're going to draw it. And that's our basic ellipse. So, notice all these formulas here. Here's, this is a vertical, so we're on the right-hand side of your page. To find a vertice, we did the H and K plus A. So 0 plus A, there was your 5. K minus A, there was your negative 5. Do I want to use these formulas? No. I just want to use where my A is, my B is, my C is, and figure out where I go from there. If you like to use the formulas, be my guest, but I think they get really kind of cumbersome. Okay with this? Alright, let's try another one. So right under this, I want you to write this formula.
Did you bring your quizzes or tests?
Unfortunately, I did not. I apologize. Okay, now, which number is larger, 25 or 16?
25.
This is your A. This is your B squared. So again, we need to find an A, a B, and a C. A is the distance from my center to my vertex. B is the distance from my center to my co-vertex. And C is the distance from my center to my foci. Now, this is a different center for this guy. We offset this. It doesn't start at the 0, 0. Where's your center of your ellipse?
1, 4. 1 negative 3.
1, negative 3. Good. So, give yourself enough space and make 1, negative 3. There's the center of your ellipse. Which axis is going to be your major? Your horizontal or your vertical? Horizontal. That's the X dot. The X goes this way. Now, an easy way to do this is you translated this, right? Instead of 0, 0, you went down 1. You went over 1 and down. Oops. You went over 1 and down 3. We translated it. Sometimes it helps to make this a new origin, kind of, because we move this around. Now, We said the x-axis is going to be our major because that's where the larger number falls. So we take the square root of 25. What do we get? 5. The square root of 16. 4. And again, we're going to do this guy. It's going to be 3. I kind of made something a little consistent so that you'd see, you wouldn't be panicked right away. And so C is 3. So now, horizontally, we're going to move over 5. If I move horizontally, do I change my x or my y? X. So I'm going to add 5 to this guy. That's going to be my vertex. So 6, negative 3. So one of my vertices is 6, negative 3. Now I got to go 5 the other way. I'm going to subtract 5 from that. So negative 4, negative 3. You okay with that? Are they each 5 away from the center? Okay. Now, your co-vertices, let's go up and down 4 off of your translated y-axis. So when I do my translated y-axis, I'm changing my y value, right? So from 1, negative 3, add 4. What do you get? 1, 1. This is called a co-vertice. The pilot and a co-pilot. And drop this down 4. So 1, good. Negative 7. Okay. Now draw your ellipse. You should be a little wider.
This is all that we do?
This is it.
And if you want us to find
Sorry.
if you said it's really big, is it big guy?
Well, we're going to find your foci. We keep it really simple. We use a normal one with the center exactly in the middle. There's not a lot that we do to this. I'm going to change it in a second, make it a little bit more difficult. Now, picture this a little bit more elliptical. When they're close, like a 4 and 5, it almost gives you a circle. It almost would look like a circle. Really, my ellipse is horrible looking now. I'm sorry. My foci are 3 away. So I'm going to come down 3. So what's this point going to be if I come down 3? 1, negative 6. Good. So I've got a focus point of 1, negative 6. And I have another one equal distance up here. Up 3. Right. Well, I'm so far off on this, aren't I? 1, 0. Okay? You okay with that so far? Drawing your ellipse? Okay. Now, we're going to throw a little curve in here.
It was like 1, 0 and
1, 0 and 1, negative 6? 1, negative 6. Okay. Little curveball. Now, I have to find the center, the vertices, the foci, and sketch this ellipse. First of all, what tells me it's an ellipse? X squared, y squared, good. X squared, y squared, and the fact that the numbers in front of them are different will tell me that it's an ellipse. I got a plus right now, I got a plus in between. And the fact that these coefficients are not the same will tell me this is an ellipse. But just like we did with your vertex where we completed the square, we have 2 squares to complete because we have 2 squares. So the first thing we're going to do is organize this together. 4x squared minus 8x, and then we're going to do plus y squared plus 4y. Okay. Now, we noticed when we did the ellipse equation that it was x minus h squared over a squared or b squared. It doesn't matter which one we use here. And it was equal to 1. That means our constant Remember that didn't have an x or a y, goes on the other side. So let's add 8 to the other side. And let's make this so that we can factor this. And make it a perfect square. Now I'm going to hit the y first, because the coefficient of y is 1, which we need it to be 1. So what's half of 4?
2.
2. So this guy to complete the square of y plus 2, what is 2 squared?
4.
4? 4. Now remember back when we were completing the square. My square coefficient has to be 1. So we took this guy for the x squared and we just factored out a 4. Okay? We had to make it 1. We did this a while back in the fall sometime. So what's half of negative 2?
Negative 1.
Negative 1. What's 1 squared? 1. Now remember this part? It was caught inside our parentheses. Remember this? So we had to distribute this first. 4 times 1, so we had to add a 4. Remember? That's one of the trickier ones, right? So we've got this. Keep the 4 out here. We add all these guys up to 16. Now remember, your ellipse is equal to 1. So I got to divide everything by the 16. And it works this way because if I had both of them the same, I would have a circle all the time. So one of them, or both of them, you could have to factor out. Now, when you reduce this, leave this in the denominator. X minus 1 squared over 4, even if it's a 1, plus y plus 2 squared over 16 equals 1. There is your formula, your equation for your ellipse.
So we divide by 16, the 4 cancels out because 4 squared is 16.
Well, 4 goes into 16 4 times. Yeah.
So now we just now got the equation.
Now we begin where we left off before. We start where we.
So 16 would be the a squared.
16 would be your a squared. This would be your b squared. So again, you're going to start with a, b, and c. So what is the square root of 16?
4.
4. That's a. What's the square root of 4?
2.
2. Good. And so let's do this guy. C squared equals a squared minus b squared. Again, you can take the square from here because those are already squared. When you take the square root up, we got another little snag. We got a radical. So we're going to reduce our radical to 2 radical 3. Good. Good, Gabe. 2 radical 3.
And we take the positive, right? Because this
We
is
always
both
take the positive because these are distances. Now, let's start. What's the center of your ellipse going to be? 1, negative 2. Good. So 1, negative 2. That's my center. My major axis is going to be my x or my y. The y. So from here, I'm going to go over 4 units up on y, 4 units down. So if I go 4 units to this y, what does that give me?
positive 2.
Good. 1, positive 2. That's a vertex. I'm going to go 4 units down.
1, negative 6.
1, negative 6. Good. That's another vertex. Okay. My minor is my x-axis because I had the smaller guy. I want to go 2 to the right. Changing my x.
3, negative
3, negative 2. What's this guy called?
2. Over
A covertex. Good. And I got to go the other way. 3, negative 2.
Negative 1,
I'm
negative
sorry, negative 1, negative 2. I got to go 2 this way.
negative 1, negative 2.
So negative 1, negative 2. Moving my x, so that's also my other covertex. Negative 1, negative 2. Now, I can draw my ellipse. Let's see if I can do this any better. Looks like a better ellipse. You can see that the further distance the A and B are apart, the better the ellipse looks. Sometimes it does look like a circle. Now, all we have to do is put your foci points in here. Now, before we added and subtracted 3. But we can't really add and subtract a radical. So all you have to do is this. Figure out what you're doing with this. Am I going to change the y or the x to go up and down?
Y.
The y. So I'm going to take my vertex, my center, and I want to add and subtract 2 radical 3. And that's all I have to do. Because I can't resolve this any further, really, right? I mean, I could do negative 2 minus 2 radical 3, negative 2 plus 2 radical 3, but I have to leave it exact as possible. So, I mean, technically you can do this. These are your foci points. Okay? So we had to complete the square. We actually had to complete 2 squares. Then we had to find all our A, B, and C. And one thing that I want you to be aware of, you see this formula? A squared minus A squared? It almost kind of forces you to remember that A has to be the larger number. Because I can't take the square root of a negative.
How can we put a comma between negative and positive?
Well, this is my x value. Oh, why did I put a comma up there?
Yeah.
Good question. No comma. You caught me. Good question. No comma. Okay? So with the A and the B, guys, you almost have to see that A has to be the larger one. That's going to tell you where your axis is. So all I'm asking you to do is find your vertex, your co-vertex, your foci, your center, like we did today, and sketch these. Most of them you're going to have to complete the square, and be careful. Your coefficient has to be 1 for you to complete that square. When you factor it out, remember to redistribute it. You've got to get it out of that parentheses somehow. So distribute it to get it out. Probably did this back in the fall.